Hi, 8th grade. This is lesson 2 of module 13. Find volume of cones. And the I can statement says, I can find the volume of a cone and the dimensions of a cone if I'm given its volume. So they start right with a step it out. There's no spark your learning or build understanding. So go ahead and read number 1. Pause the video, look at it, try to do it on your own, and then we'll come back and work on it together. So let's look at number 1. In a right cone, the line drawn from the vertex or tip, so that's here, perpendicular to the base passes through the center of the base. So they're saying if they drew a line straight down from the vertex to the base, it would pass through the center of the base. And that's called the height of the cone. So that would be the height. You can use the following reasoning to develop a formula for the volume of a cone. A says, consider a cone with a radius r and the height h. So they're looking at this here. It has a radius here and the height is h. Imagine that the cone is made of cardboard and has an open top as shown. Also consider a cylinder with the same radius and the same height. You can fill the cone with sand and pour the sand into the cylinder. It takes 3 of these cones to fill the cylinder. So that means that the volume is of the cone is 1/3 the volume of the cylinder. And I just noticed that this little number 3 here is not completely visible, so make sure that that's clear. So let's look at B. Complete the following to write a formula for the volume of a cone. The volume of a cone is 1/3 the volume of the cylinder, so that's going to be 1/3 times the base times the height, which equals 1/3 times pi times the radius squared times the height. And remember, this pi times the radius squared is what is also the same as that capital B here. So let's look at the next question. All right, so let's look at number 2A. They're telling us that we can use this formula to find the volume of a cone when you know or can calculate its radius and height. A, the cone-shaped party hat shown here has a radius of 3 inches. And they say find the volume of the cone, and they want you to use 22/7 for pi in this case. And they do that here. They kind of fill that in for you. So we're just filling in the blanks. So we have 1/3 times 22/7, which is pi, times the radius, which is 3, times the height, which is 7, and that's over here. So this is 3 squared, so that would be 9 times 7. And so if we calculate that out, it equals approximately 66. So the volume of the cone is approximately 66 cubic inches. So let's look at B. Find the volume of the cone, leave your answer in terms of pi, then approximate the volume by substituting 3.14 for pi and rounding the volume to the nearest tenth. So I'm not going to go through this whole thing with you. I'll just get you started with these first 2 fill in the blanks, and then you can finish on your own because it's very similar to the first problem. So they show you here, this cone, they show you the diameter, not the radius. So you have to think about that each time. So they tell you the diameter is 10.2 centimeters. So you know then that the radius is half of that, or 5.1 centimeters. For the rest of this, use this volume formula and just fill in the blanks and do the calculations on your own. So then once you're finished with that, we'll look at the next question. So number 3 says the slant height of a right cone is the distance from the vertex of the cone to a point on the edge of the base. So this is the slant height. This is the height of the cone, but the slant height is going to go along the edge, the outer edge of the cone. You can find the volume of a cone if you know the radius and the slant height by using the properties of right triangles. Find the approximate volume of the cone shown. Use 3.14 for pi and round the volume to the nearest tenth. So try A and B on your own, and then we'll look at those together. So pause here, work those out, and then we'll go over them. So if we look at A, first find the height h of the cone. So that's here, or this would be the height. And this triangle here is the same as here, and so I think they put that there to kind of give you a little bit of a representation that you're more familiar with. And so all you're going to do is plug in using the Pythagorean theorem. So the height squared is just, or the h is the height, that's just another leg of that right triangle. So you have h squared plus 6 squared, the other leg here, equals 14 squared, which is the hypotenuse, or the longest side. So h squared plus 36 equals 196. 14 squared is 196. So h squared would equal 160. We subtract 36 from both sides and we end up with 160. So we know that h equals approximately 12.65. So now that you have that, you can plug that in over here at B. So they have 1/3 of pi, which is 3.14. They told you to use that. The radius is 6, and the height is 12.65. So you're just using the information that you figured out over here into this formula that we have here for the volume. So 1/3 times 3.14 times 6 squared is 36 times 12.65 again. And that equals approximately 476.7 when you round to the nearest tenth. So the volume of the cone is approximately 476.7 cubic millimeters. So that's the end of this lesson. I will see you in the next lesson.